Hi everyone, welcome to the Bio Edge.
When it comes to the biogeography and ecology of New Zealand, it sometimes seems that everything we thought we knew about New Zealand is wrong. And we'd like to give an example here at the Bio Edge involving the frog fauna of New Zealand. Now, a glance at the map will quickly establish that New Zealand is by far the most isolated large landmass on the planet that's habitable to animals and plants, simply because it's a fairly large archipelago, but it's remarkably remote from any other land mass. And so it presents a unique test of evolutionary principles in the sense that it's hard to get to, and it has a peculiar geological history in terms of plate tectonics and continental drift. And so it's a kind of an extreme testing ground, as it were, of what we think is our understanding of how living things come into existence. Now, in order to assess the real fauna and flora of New Zealand in a meaningful way, to interpret it in a way that we can learn something from it, we really need to generate some kind of expectation of what we should find in New Zealand. And that's the hard part. It's all very well documenting the biota of New Zealand, and that's been done very well now. But the field of understanding New Zealand is still in its infancy, simply because it's one thing to establish the facts. It's quite a different thing to interpret them meaningfully. And in order to interpret New Zealand meaningfully, we really need to have a prediction. We need to make a firm prediction of what we should find there, and then compare that with what we actually do find there. Now, most listeners will be familiar mainly with the situation in mammals and birds. And it's fair to expect that mammals would not have reached New Zealand simply because of its isolation, except that when New Zealand broke away from Gondwana 65 million years ago, there were mammals around, as we know from the monotremes in nearby Australia. And so that assumption is not fully warranted. It's quite possible that some mammals were present in Zealandia when it actually broke away at the end of the dinosaur era. And when you think deeply about it, the assumption that mammals have not reached New Zealand across the sea is also questionable, because we know that there are 3 species of bats native to New Zealand, and the question then arises, well, why didn't these bats evolve terrestriality? And indeed, the pinnipeds, the seals and sea lions that continually reach the shores of New Zealand could theoretically also have re-evolved a land-living habit. And so it's not that easy to interpret the absence of fully terrestrial mammals in New Zealand. It's not as easy as it sounds at first glance. Initially, it seems like, well, it's obvious there should be no land mammals, but the more you think about it, the more peculiar it becomes that there are not land mammals. And we now know from the fossil record that there was at least one small land mammal present until several million years ago. And so the point is that as far as mammals are concerned, we're back to square one. We really do not understand why there are no land mammals in the native fauna of New Zealand. With birds, again, superficially, it sounds like an easy thing to assess, but it's not really, because everyone knows about moa and kiwi as being flightless birds. And so it's easy to assume that these rather primitive flightless birds were present in Zealandia when it broke away from Gondwana 65 million years ago. But now, the latest molecular analyses have indicated that both moa and kiwi are derived from small flying birds that actually reached New Zealand much later across the seas, and then evolved into these bizarre flightless forms that we now know as birds extremely characteristic of New Zealand, moa and kiwi. Now, if that's true, if moa and kiwi, which are so different even from other flightless birds such as emu and rhea, evolved in situ in New Zealand from completely different ancestors, then again, why is it not possible for a partly terrestrial bat or a sea lion to evolve into fully terrestrial forms on the same islands? So there's a problem of consistency. Now, to come to the point about this particular biobullet, which is focusing on the frogs, let me ask listeners, what would you expect the frog fauna of New Zealand to be, given that most people know a little bit about mammals and birds in New Zealand, but relatively few people have even thought about the frogs of New Zealand? Well, if we told you that New Zealand is a large and wet and rainy archipelago, lots of mountain streams, lots of volcanic lakes, lots of springs, lots of wetlands and waterways, lots of fresh water in general. One of the nicest places for frogs on the planet, we would have thought. Would you expect there to be a decent adaptive radiation of frogs? I certainly would, based on everything else I know about frogs. And if it's indeed true that frogs were already in existence 65 million years ago, which the fossil record does confirm, then presumably frogs should not have had to reach across the seas to get to New Zealand. They would be there already in the original fragment of Gondwana that drifted off and eventually became New Zealand. And so my expectation would be, based both on accessibility and on evolutionary opportunities, that we would find an extremely diverse fauna of frogs in New Zealand, presenting a nice adaptive radiation, perhaps similar to what we see in honey creepers in Hawaii or Darwin's finches in the Galapagos, and that New Zealand should be renowned as being a center for frog diversity, a nice endemic radiation. But unfortunately, that reasonable expectation is shattered when you look at the reality of frogs in New Zealand, because although frogs were originally widespread in New Zealand when humans first arrived, and 3 species remain in existence today, nonetheless, the enormous disappointment about frogs in New Zealand is that their adaptive radiation is extremely limited. One could say that there is no adaptive radiation in New Zealand frogs, because the only frogs found there are small, primitive, generalized forms, probably representative of what was in Gondwana at the time. And they're semi-terrestrial. There are no burrowing frogs, no climbing frogs, and even the most expected form of frog, which is a fully aquatic foraging tadpole, is absent from the frog fauna of New Zealand. And so you could say that although frogs were widespread in New Zealand, the fauna is desultory in the sense that it has failed completely to radiate into the many niches that would seem to be just waiting to be filled by frogs on this archipelago, which is also ostensibly suitable for frogs in having relatively few predators, at least mammalian predators. And so now we have a real interpretive problem, because we have a group that definitely did reach New Zealand, and in that way is different from mammals. We absolutely know that frogs reached New Zealand because there they are, and the family Leopelmatidae is found nowhere else. But they didn't radiate. They did not do anything with the opportunities that they had for 65 million odd years. And so one wonders, well, how much longer do the frogs need to do the obvious, which is to go out and diversify and specialize into the various niches that we see on other land masses. Now, to give you 2 examples of land masses that provide a relevant comparison, the Seychelles, which is another nearly drowned continental fragment of Gondwana, is only 1/600th of the land area of New Zealand, but that still retains 2 families of frogs and 3 genera of another group of amphibians, the Sicilians. And so the tiny Seychelles, tiny little granite islands stuck out far into the Indian Ocean, have got a more diverse amphibian fauna than the entire archipelago of New Zealand. How does that work? And secondly, if you go to Patagonia, which reaches similarly extreme latitudes in the southern hemisphere, and is in many ways a comparable fragment of Gondwana that remained far south on the Earth, Patagonia has an extremely diverse frog fauna, with something like 6 or more different families radiated out into traditional aquatic forms, burrowing forms, large forms, small forms, climbing forms, etc. So Patagonia has had no trouble in filling all of the niches with frogs, and the fauna of Patagonia is overwhelmingly endemic, radiated locally from perhaps some kind of Gondwanan ancestors that have been completely transformed into essentially South American families of frogs. And so the point of this bio-bullet then is to point out that when it comes to the frogs, neither the Gondwana heritage approach nor the natural selection approach really explain much about the New Zealand frogs at all. In terms of the Gondwana heritage, the kind of accident of history, well, certainly the Leopelmatidae of New Zealand would appear to be Gondwanan frogs, but then why is it that none of the other Gondwanan lands, Patagonia, South Africa, Tasmania, the rest of Australia, none of these lands have any kind of taxonomic link with the New Zealand frogs? They all have completely different frog families, and so there is no Gondwanan frog fauna to speak of that we can point to in order to say, well, all that is needed to understand the frog fauna of New Zealand is to realize that it's a relic of Gondwana. That doesn't work because there is no Gondwanan frog fauna that's ever been established, and so that explains very little. When it comes to the powers of natural selection and the actual changes that we expect from evolution over an immense period like 65 million years, well, we've seen those processes in evidence on the other southern lands. We know from the Patagonian fauna that there's been an evolutionary radiation, and the same kind of process can be seen in Tasmania. There's a decent frog fauna involving 2 families and many genera. And so there's a very reasonable expectation of a diverse frog fauna in New Zealand, and yet the expectation is shattered by reality. And so where does that leave us? Well, essentially it leaves us back at square one. Although the biota of New Zealand is now thoroughly documented and has been analyzed with great sophistication in terms of its molecular affinities, essentially the textbooks have nothing to say in terms of intelligent and meaningful interpretation of how the New Zealand fauna came to be the way it is. And that's very nicely exemplified by the frogs, which really stump us. We're completely mystified by the fact that frogs are present and widespread in New Zealand and yet are so desultory in their failure, as it were, to evolve in any way that matches the kind of prediction you would generate based on evolutionary theory and based on what you see on other land masses of comparable history and comparable climate and even comparable geology. And with that tantalizing call to arms for the biologists of the world to solve this problem, we look forward to seeing you next time.